All right. Um, so this is, I hope this is Computer Science 46A. So we're going to be combining the lecture and the lab session, so we're going to be meeting every Tuesday. When is it? I don't remember. Okay, it's every Tuesday and Thursday. When do we meet on Tuesday?
10:30.
12, right? 12 on Tuesday, and then 10:30 on Thursday, and then we have a lunch break, and then we meet again at 12, which is a little weird, but that's how they set it up. So it's the first course in computer science, and I put together a green sheet, and it's boring, but at some point you might want to go through it. And I give you a link for that, as I'm required by law. There is my office hour information is also there, and if you just Google for my name, that site should pop up. So the goal, there are kind of three goals: to learn to program in Java, learn fundamental computer science concepts, and probably most importantly, to learn good software engineering, good programming habits. It's the first course in computer science, so our fervent hope is that all of you will graduate with a degree in computer science. And so actually, it used to be that it was very easy to motivate people to go into computer science. When I did this thing maybe 10, 15 years ago at the height of what was called the dot-com boom, everyone wanted to go into computer science because that's where the money was. You'd work at a startup, a few months later the startup would go public and you'd have $1 million in stock, and what was not to like? And so in the intro class, it was twice as full as it is now. So everyone wanted to do it. And more recently, of course, not so many people were interested in it. And so we've actually, for a while, had very few people entering computer science. Now it's started to tick up again, but still people sometimes have to convince their parents, why the heck should I go into computer science when everyone knows that my job will be outsourced to Kuala Lumpur tomorrow? And so if you need to tell your parents why, there's all sorts of sensible reasons. I'm giving a link here where I think the ACM says that this or that organization says it's a great job and all of that, and that's socially relevant and all of that. But the reason I'm sticking with it is actually it's a lot of fun. Maybe I don't look like a fun-loving guy, but it really is. It's an interesting subject, and maybe for an odd reason, and that is that unlike what most people think, most people seem to think computer science means you sit in front of a machine, you interact in symbolic ways with it, and it sounds like maybe a little boring, but it's incredibly creative. And the thing what you do, and what you're going to learn to do even in this course, is that you're going to create new things that have never been there before. And that's kind of what humans like to do. We like to create new things that have never been there before. And in computer science, it's actually easier than in most other fields. Now, if I were to write a novel or if I were to produce a sculpture, that would take a long time. It would be really hard. But I can take a program that does something, and in a matter of hours or days, turn it into something that does something nicer or better or more interesting or weirder. And I get feedback all the time. It works a little bit better, a little bit better, a little bit better. Writing a novel, on the other hand, must be awful. Because for months and months, you don't really see how it hangs together and how it's something that other people would enjoy reading. Whereas with a computer program, once things start working, you're in a positive feedback loop that many people find very energizing. So, and it really is kind of amazing. You dream of something that you want the computer to do, and you spend a few hours of grueling suffering and planning to get it going. But then once it starts working, it really is amazing to see how this dumb machine executes in incredible speed what you have dreamt up. And you're the master, and it follows what you do, and the good things and the bad things that you came up with. And it really is, it's an amazing sight that many people just find very satisfying. And the other thing is, of course, eventually you're going to start building things that are good enough that other people want to use them. And then when you see other people use your stuff, that's another feeling of great satisfaction that people have. That's to say, I built this thing, and now 1 or 2 or 10 or 1,000 other people use it. So when I was a graduate student, I wrote a program that I needed for my own use, and I showed it to some friends, who showed it to some friends, and then someone called me up and said, "How much is it?" And I had no idea. I said, $50. And I got a check. And for the next few years, I got checks in the mail all the time from people who wanted to use my stuff, and it was worth it. And it ended up costing $300 later, because it turns out it's easier to get someone to write a purchase order for $300 than for $50. But still, it was so people wanted to use what I had created, and so that was more interesting actually than the money that came out of it, which wasn't bad either. But it really makes you feel that you're doing something that other people want to use. So it is a very interesting field, and it's something that many people find very rewarding. And it's not the easiest thing to get into. There are disciplines that are definitely easier, but I think people stick with it because they enjoy that. It's a fulfilling discipline. It really is. And so every morning I still do a lot of programming, and I still enjoy it tremendously. And so I never have to drag myself out of bed and say, "Oh my God," except for the teaching part. But no, just kidding. The other thing is, of course, that it does pay the bills, and it has done so even at the times when everyone said, "Oh, it's terrible," and it's all being outsourced. And so if you Google for best jobs 2011, you're going to get a bunch of hits, and I just put up the first two that seem to have some credibility, and they rate software engineers the #1 job. When I did this a couple years ago, it was even better, because the #1 job was software engineer, and the #2 job was college professor, which now unfortunately doesn't seem to be rating quite as highly, but you can't have everything. So there is a shortage of people in the field. Every qualified student who we graduate has found a job very quickly, often even before graduation. So it's not something where you'd have to really worry about what's going to pay the bill. You're going to pay the bill. The other thing that people like once they are in a job is that many times they have a lot of independence and have a certain amount of freedom. When last time I worked as a programmer and I wanted to take my kids for vacation, my boss mumbled something about that this might not be such a good thing, and I said whether it was okay with him that I continue working for him after I come back from the vacation, and there wasn't much of a question. But if you know what you're doing, if you're an expert in your field, you have a certain amount of control over your workplace, and it's not like a job where you always worry about someone telling you what to do in minute detail. And so having that creativity, having that kind of control, that structure, is something that a lot of people find very pleasant. So it's not just that it pays well. Obviously, there are jobs that pay better. Divorce lawyer comes to mind. But that may not, some people may find it a satisfying job. So it's a good career. So what's wrong with it? The bad part about it is you never stop learning. That every day I spend a half hour, an hour or so figuring out what's new, what's changed, what do I need to learn next, and then I might spend an hour or two on learning brand new stuff so that I keep myself up to date. And that's something that you're always on this treadmill that you have to just keep yourself up. If you enjoy what you're doing, that's great. But it's probably not a good field for if you don't like what you're doing, because you really have to keep on learning. Me, I enjoy learning new things. It's much nicer to learn something new than to do the same thing over again. But that's a mindset that people in this field have. So what do computer scientists do? Well, of course, a good fraction, you can see about a third of them code. But about 2/3 of them do not actually do a lot of coding. They're people who they interact with other people. They'll interact with people who want to put systems to place. They want to design systems that they might manage other programmers. They might do research. So it's really kind of up to you what you do with the degree. It's a very flexible degree. Many people start out doing hardcore programming, but they're eminently employable elsewhere. Most of the tech companies in the Valley recruit their managers from computer scientists, because after all, you can teach a computer scientist how to run a business, but you can't teach a business major how to run computers. And so it's just a flexible degree. The same thing happens to also be true in things like biology. There's now a lot of things going on with computational biology. We run courses where computer scientists and biologists are taking a course jointly. And it turns out it's a hard course to teach because the computer scientists can learn the biology. They have learned how to learn quickly. The biologists can't learn the computer science. So we like to think of ourselves as being people who can learn stuff quickly, who know not just how to do the programming, but also how to put it to work to solve real problems. So what are we going to do in this particular course? Of course, and that's always a big disappointment to people towards the middle of the semester, that you start out, you want to build all these great things, but then you are in the middle of the semester and you've just learned how to tie your shoelaces. But I mean, that's life, right? You can't learn everything in the whole semester. So we're going to be starting out with the most fundamental of programming concepts that everyone needs. Can I just have a show of hands? Who of you has had a programming course before? Okay, so that's about half the class. It's not a prerequisite, and so those of you who've had a programming course, you know what variables, functions are. You may know what classes are. So we're going to be doing the basic building blocks that you need to write a computer program. We're going to be doing it with Java. It just simplifies to use one language. Java is a pretty good language for this purpose, and whether you've had Java, like I said, it's not a prerequisite that you had any programming at all. If you had Java before, you may be under the illusion that you have an advantage, but that'll soon vanish because we're going to be using it from a different point of view than what you've probably seen before. We're going to stress not so much the minutiae and the syntax of the programming language, which is going to change over the years anyway, but more the fundamentals. How do you go by designing a program? How do you go design the pieces of a program that are called algorithms? We're going to be spending some time on how do you do planning, testing, and debugging, because one of the frustrating things is that if you have an even moderately complex task, it always takes much longer than one thinks, and it never works as well as you think. And you need to plan ahead as to how you deal with that. That you can find out, when do you need to start, what do you need to test, and all of that. So we're going to be spending some amount of time on those kind of soft skills. And an important thing is you're going to learn how to learn something that's much more complex and what's changing much faster than most of the things that you've learned before. When you learn mathematics, you learn over 8 years or so a corpus of knowledge that has not changed for 150 years. And it's you learn it at a slow pace. And the idea is that you learn it with complete understanding, that at every time you should, in theory at least, understand everything exactly what you're doing. And computer science is not like that. There's so much stuff that one would have to know to have a complete understanding that one has to be satisfied with having a partial understanding, just enough to get some work done. And then the rules change all the time, and you have to find help somewhere. You have to find help on the web. You have to find help with your friends. You have to figure out how can you quickly dig into a very specific thing that you might need for a project, even though much of the stuff that surrounds it is going to be unfamiliar to you. And you're really going to learn how to be better learners in the process. So that's something that has really changed. When I first taught this 30 years ago, computer science was much more like mathematics. You could know all the rules. And it was kind of satisfying. There was a small number of rules, and you could write a program that printed all prime numbers or something like that. But nowadays, most people say, how interesting is it to print all the prime numbers? I have these computers that are all around me that do exciting things, that show world maps, that show rotating globes, that let me play games and things. And so students have much higher expectations. And so we try to lead you towards those expectations more. But the flip side is you're also going to have to be willing to take some things on faith. And you have to just going to be able to rapidly learn snippets of facts and small subject matters that you need to do some more exciting effects. So like I said before, no prior programming knowledge is required or expected. We're going to be starting from the very first steps. Of course, it can never hurt to know a little bit, but it's not going to be as useful as you think. What I usually find is that the students who've had a course in high school, even an AP level course, that they do very well the first 6 weeks, and after 6 weeks everyone has caught up. And sometimes actually the students with prior knowledge get overconfident and then they fall behind because they don't see that the complexity is ramping up beyond what they have had experienced before. So if you've never written a line of code, that's just fine. So the other thing that I want to do in this course is I want to change your brain. And if you think about it, the only reason that you're learning something, that you assemble here and take a course, is because you want your brain to be different afterwards than it was before. Otherwise, it's all going to be a big waste of time. And it turns out that to change some